Hello. Hello, can you hear me?
Yes, sir.
Yes, sir.
So let me share the screen first. Can you see the screen also?
No, sir.
No, sir.
Now you can see, right?
Yes, sir.
So you have any doubt? If you have any doubt, let me know first. Hmm? Who is that? Where are other students?
ना ना मुझे फोन आ रहा था भैया
Who is Priyansh Raj? Priyansh Raj, just now you send one email. Are you here, Priyansh Raj?
आगे जाना ओए
Priyansh Raj, are you here?
सर
Priyansh Raj?
हेलो यस सर
Yeah, so you wrote one email. What is that? What do you have?
सर जो आप ये आई कैलेंडर शेयर किए हैं उसका
अरे वो आई कैलेंडर मैंने शेयर नहीं
डाउनलोड
किया।
करने पे कुछ इंपोर्ट नहीं आ रहा है।
मैंने आई कैलेंडर शेयर नहीं किया, मैंने शेयर किया लिंक। तुम्हारा 4 अभी क्लास है हर हफ्ते में, है ना? तो मंडे का जो क्लास है वो कल शेयर किया था। उसी लिंक में नेक्स्ट वीक भी ज्वाइन करना है मंडे के लिए। आज का जो लिंक है वो हर ट्यूसडे ज्वाइन करना है। कल और एक भी लिंक भेजेंगे हर वेडनेसडे के लिए, इस तरह। हाँ,
ओके सर
और मटेरियल तो अलग से भेजे हैं, उसमें और कुछ नहीं देखना है, ठीक है?
ठीक है सर।
बोलो, किसी कोई डाउट है?
नहीं सर थैंक यू।
कोई भी डाउट नहीं है? बोलो, व्हाट डू यू मीन बाय ए सीक्वेंस? प्रियांश राज, हेलो प्रियांश राज।
यस सर
Yeah, can you tell me what do you mean by a sequence?
रिकरेंस ऑफ numbers real numbers in a different pattern is called sequence.
Yes, what a recurrence?
मतलब रिकरेंस में ज्यादा सही नहीं रहेगा, लेकिन अगर ये चीज बोले कि कोई एक डिफरेंट पैटर्न में अगर नंबर सिस्टम अपने आप को अरेंज करता है जिसका हम लोग एक पर्टिकुलर फॉर्म निकाल सकते हैं, उसको सीक्वेंस करना ज्यादा बेटर रहेगा। जैसे प्रोग्रेशन जिस तरीके से हम लोग पढ़ते हैं वो,
जैसे क्या पढ़ते हो?
जैसे कि प्रोग्रेशंस अर्थमेटिक प्रोग्रेशन ज्योमेट्रिक प्रोग्रेशन एक डिफरेंट पैटर्न में आते हैं।
तो एक पर्टिकुलर, so sequence is a mapping form. If we talk about real sequence, right? Suppose then sequence is a mapping from natural number to real number, right?
ये
That
सर
means f of 1 will be some number, f of 2 will be, so f of n. This is a sequence. So sequence is a mapping from natural number to.
Sir, please can you use the red pen?
Okay. So red pen, where I should find it? Where is the red? Maybe here, right? So sequence is a mapping from natural number to this you already have studied, right? Now you have to just recall. Sequence is a mapping from natural number to,
A real number.
if it is a real sequence, then natural number to real number. If it is a complex sequence, then from natural number to
Complex numbers.
complex number. So that means it's a mapping from natural number to some field. Okay, so here if the field is real number, then it's a real sequence. If the field is complex number, then it's a complex sequence. And till now, what you have studied for sequence? First, you have studied the motivation, why you need to study sequence, right? And what example I gave? What example I gave to study sequence? Why you need to study the sequence? Can anyone tell me? Rajiv, Rawat, Rajveer, Tushar Yadav, Tushar Yadav is here. So anybody is from Rajasthan? Hello. Anybody is from Rajasthan? Some student emailed me that there are some problem in the internet. There's some curfew going on. Okay, bro. So your internet connection is stable there in Rajasthan, or you don't have now internet connection? Internet is banned or what? Okay, in Jaipur it is stable. Okay, so you have any doubt? Why you need to study sequence? Nobody. Can anyone give some answer why you need to study sequence? We take one example, right? If you want to find the area of a circle, so first you have to, suppose you want to find the area of n-gon polygon, right? The area of the n polygon. Then you can see if n tends to infinity, what will happen. That means you have to study what will happen after for the tail of the sequence. That is mean by convergence of the sequence. Then also you have seen the boundedness of the. What is happening? Hello?
Yes, sir.
What is happening? You have log out or? Then you have seen boundedness of sequence, right? You have any doubt till now? Then you have seen that convergence sequence is bounded, but the converse may not be true. And you have got some example, right? What is that example? That a sequence can be bounded, but it may not be convergent. What is the example? What is the example?
-1 to the power n.
Yes, -1 to the power n. That sequence is bounded, right? but the
Yes.
sequence is not convergent. Can you give some another example? The sequence is bounded, but sequence is not convergent. Can you give some another
Sir,
example?
sine n pi by 2.
Yes, sine n pi by 2. So it will be bounded by, it is bounded above by
1
1 and bounded below by
-1.
-1. And why this sequence is not convergent? How will check the sequence is not convergent to a unique real number? Can anyone tell me? No one? Why this sequence is not convergent? It can be proved in many ways. One is via epsilon n definition. Another one is later on we'll study subsequence. What do you mean by subsequence? Then there also you can show that if two subsequence of the same sequence converges to different limit, then the sequence is not convergent. Through that also you can prove later on. We'll see. But for the
Sir,
time,
the screen is not visible.
screen is not visible.
No,
Yes,
sir.
sir.
Black दिख रहा है. Black दिख रहा है.
Okay, let me see.
Yes, sir. Screen not visible. Now it is visible, sir.
हाँ सर.
Now it is
अब
visible,
हाँ
sir.
अब दिख रहा है.
Okay. So what happened? Maybe somebody has logged in and then it logged out. Some other faculties. Okay, so how we'll know that this sequence sine n pi by 2 is bounded is clear, right? But not convergent. So how will show that this sequence is not convergent? We can use this epsilon n definition, and later on we'll see via subsequence. Okay, we have not studied. Okay, so after that you have studied also monotone sequence, right? After that you have studied monotone sequence also, and then also you have studied algebra of limits. Suppose two convergence sequence is there, then what will happen? Their summation will also converge and converge to their additional limit, then their subtraction limit. Product of the sequence will converge similar to the product of the individual जो sequence का तुम्हारा limit है उसका product. Similarly division का, provided that denominator is not 0 and the limit of that sequence is also not 0, right? Is it clear?
Yes, sir.
Okay, so let me see whether it is clear or not. So what will be the limit of this sequence? Suppose limit n tends to infinity.
अरे इसमें पढ़ता हूँ लेकिन आता नहीं है मुझे समझ में।
कौन है? 3n square plus 2n plus 1 n square plus 1. So what will be the limit of this sequence where it converges? How will check? So it's maybe it would take long time if you want to show via epsilon n definition. So that's why this algebraic property of the sequence of limits will be useful. So what you have to use? What you have to use? If you want to see where it converges, I will show it. Tell me where it will converge.
3.
3. How you get it?
L'Hopital.
I have not talked about L'Hopital's, right? Whatever you have studied, you have to use that.
N square common ले लेंगे सर लोग।
So this
And
will
square
be,
से divide कर
ऊपर ही divide कर देंगे.
and square से ऊपर नीचे divide कर।
so this will be, there will be two sequence, right? So it is like your UN sequence and it is like your VN sequence, right?
Yes, sir.
And now you have to use algebraic property that if there are two sequence UN and VN, okay, so UN is like your 3 plus 2 by n plus 1 by n square, right? And Vn is your 1 plus n square. So what will happen now? So UN converges to this sequence, UN converges to 3 because you know here also you can use algebraic property, right? This sequence 1 by n converges to this sequence 1 by n converges to 0. The sequence 1 by n square converges to
0.
0.
Zero.
And we have also studied that if x and y and converges to x and y, then their summation will also converges to x plus y. And similarly, it will hold for 3 sum of the sequence, 4 sequence and their sum, right? So UN will converges to 3 and VN will similarly converges to
1.
1. So you can see that Vn is not equals to 0, right? For all n greater equals
Yes,
to
sir.
1 because Vn is in the denominator and V is also not equals to 0, right? So limit n tends to infinity, Un by Vn will be equals to limit n tends to infinity Un Vn. So UV, so U is your 3 and V is your 1, right? So using algebraic property, you can prove limit of many other sequence also. Suppose it is given in some rational function form, okay? Some Un by Vn type of form it is given, then you can similarly use it. Then you have studied sandwich theorem, right? So what do you mean by sandwich theorem? What do you mean by sandwich theorem or quiz theorem? So there are 3 sequences An, Bn and Cn, and suppose values of Bn lies between An and Cn, right? For some n not onwards, even it's also possible. Then if An and Cn converges to some number L, then Bn will also converges to L.
Yes, sir.
So do you have any difficulty using this sandwich theorem?
No, sir.
No, right? So suppose x belongs to R, okay? And suppose 0 less than x less than 1, okay? Then what will happen to this sequence x to the power n? Can anyone tell me? What will happen to this sequence xn?
Converges to 0.
Yes,
Sir,
how you,
conversion to 0.
yeah, how you know?
Sir, because x is between 0 to 1 and for n tending to infinity it becomes 0.
Yeah, but how you know which theorem you have used? Which theorem you have used? Which theorem you have used? I told you yesterday, right? That when you have studied some monotonically increasing and decreasing sequence, that time I told you 2 properties. right? That if the sum sequence is monotonically decreasing and bounded below, what will happen? What will happen? So every monotonically increasing sequence which is bounded above, what will happen?
Sir, an plus 1 greater than or equal to an.
That is for every monotonically increasing sequence. Suppose first we are writing every monotonically increasing sequence which is, if it is increasing, then what should happen? Which is bounded above or below? Above. Every monotonically increasing sequence which is bounded above is convergent, right? Similarly, every monotonically decreasing sequence which is bounded below is convergent. Now this sequence an is monotonically decreasing or increasing?
Decreasing, sir.
Decreasing, right? And it is bounded
Decreasing,
below
decreasing.
by
0.
0,
0.
right? So it will be convergent. And how will prove this? Using Sandwich theorem also you can show that this sequence will converge to 0. Okay, how will show it? If you want to apply suppose Sandwich theorem, how will show it? That xn goes to 0 as n tends to infinity when this mod x even less than 1. Okay, I will show it. Anyone? Can you guess it? So when mod x is greater than less than 1, that means 1 by mod x is greater than 1, right? Then how will show it? So there are some standard techniques, okay? So there are various properties. Suppose limit n tends to infinity, x to the power 1 by n, x where x is positive. What will be the value? Do you know? X is positive, huh? What will be the limit of this sequence?
1.
1. So how will prove it? This need a proof, right? So how will prove it? So first this statement. So suppose x lies between 0 and 1 or in mod x minus 1 to 1 strictly, huh? So either in open minus 1 1 or in 0 1. Okay. So this is there, and if you take 0 less than x less than 1, then okay. So in both case, we can prove that this sequence xn tends to 0 as n tends to infinity. Okay, so how will prove it? How will prove it? So there are some standard technique. So since this is greater than 1, so you can write Is it clear? So mod x less than 1. So 1 by mod x greater than 1. So you can write 1 plus some positive number. Is it clear till now? Is it clear or not?
Sir, I have a question.
Yes.
Sir, what we have to prove?
This you have to prove. The sequence xn converges to 0 as n tends to infinity, where mod x less than 1. Okay. Suppose there is some sequence xn where mod x is less than 1. Now you have to show that this xn tends to 0 as n tends to infinity when mod x less than 1. Via sandwich theorem you want to prove it. Okay. The sequence xn, suppose sequence xn or you can say rn है जहाँ पे तुम्हारा mod r less than 1 है, you want to show that
One
this
है.
sequence goes to 0, okay, as n tends to infinity.
तो
Suppose
सर अगर
up to the power n, okay, this sequence, so r is mod r less than 1, x, suppose x you have take half to the power n, this sequence goes to 0 via this if you prove this property. Now you have any doubt till now up to this?
No, sir.
Okay. Now what I should write here using whatever you have studied, using 1 plus h to the power.
So it's a binomial expansion.
Yes, binomial theorem. What should I write?
1 plus h की power n equal to 1 plus nh.
nh plus up to last term will be h to the power
h square.
huh?
n.
n. Now what should I do? So suppose you want to apply binomial theorem, right? And you want to show, so like since is mod, so like this type of things you have to show ultimately, because this is mod, this will hold and this will be bounded by some sequence, then you can apply some sandwich theorem. Okay, so can anyone tell me from here what will be that one? So this will be, can anyone tell me? So you have to use just one trick to get that sequence, which is, and you know the limit of that sequence. Can anyone tell me? Is it okay? What I have did? What I have did here?
So
This, what I should do here, this should be, this should be, this should be
1 plus
this should be,
nh.
this should be greater than nh, right? So this should be greater than nh, because here 1 plus all these terms are there, and here in the right hand side I have written only one term, right? So 1 plus a, yes, and h is positive. Okay, n is already your natural number, so this is greater than n. So what you have got, that 1 by x to the power n.
Sir, so we can take up any term of this sequence like this.
Yes, but you have to careful that whatever you know, that whether you know the limit of that sequence, okay, whichever is bounded by that sequence, an lesser equals to bn lesser equals to cn. So n is already 0, right? And cn is, you have to find it. So you don't need to make complex, right? Just trivial sequence you need to take. So what will happen from here? That x to the power n is less than from here 1 by nh. Is it clear or not?
Sir, but this
Mhm.
h is very small number, sir. Then,
Then what will
sir,
happen?
then sir, 1 upon ns will become very large.
If x is,
Sir, this h is very small number here, then this 1 upon ns will become very large.
no. Why?
Sir, because h is in denominator.
This is 1 by nh. So this will be very small number, right? 1 by nh will be small or not?
Yes, sir.
So this is h is fixed,
Sir.
right? 1 by
Sir,
h.
1 by nh is very big number, na?
Which one is big number?
Sir, h is very small number.
Huh?
N tends to infinity, h is small number.
So 1 by n is big number or a small number?
Small number, sir.
Sir,
वो शायद पूछ रहे हैं कि h स्मॉल नंबर था लेस देन 0, तो उसको जब डिनोमिनेटर में गए तो बड़ा नहीं हो जाएगा फिर, बट n
ये-
इंफिनिटी है तो 1 बाई इंफिनिटी बनेगा तो वो 0 को
So
टेन
this is 1 by n into 1 by h, right? And this total
sir.
number will be small or big?
स्मॉल सर.
Small, right?
sir, small. Yes, sir, confirmed.
Okay. And this you know already, h is fixed here. Okay. This you know already, this sequence. And this goes to, this sequence will goes to where? One by n is this sequence will goes to, कोई तो बताओ.
Sir,
Huh?
0.
0. Right, this already you have studied. Suppose 1 by n goes to 0. Then by the algebra of limits, if xn sequence goes to suppose 0, then c of xn sequence will goes to, suppose is goes to x. Then c of xn should goes to, for some real number c, what should happen? C goes to, cf of xn goes to cx. Right?
Yes, sir.
So this is sequence will also goes to 0. So by sandwich theorem, limit n tends to infinity. What is happening? Limit n tends to infinity. X to the power n equals to 0 when mod x is strictly less than 1. So now from here you can see that this all this sequence, right? 1 by 3 to the power n, 1 by 4 to the power n. All this sequence will goes to 0. Okay. Now similarly, can anyone prove it? That for x positive, limit n tends to infinity, x to the power 1 by n should goes to
1.
1. So how will prove it? How will prove it?
That 1 by 1 goes to 0 and x to power 0 is equal to 1.
So you need a proof, right? And how will prove this? Suppose x equals to 1, what will happen?
Sir, this will be 1.
1. Suppose 0 less than x less than 1, what will happen? And suppose x greater than 1, what will happen?
The number will be greater than 1.
Yeah, so you need case-wise proof, right? if you want to apply sandwich theorem, suppose x greater than 1, then how will prove it? So if x is greater than 1, what will happen for the term x to the power 1 by n? If x is greater than 1, what about this one? What it should happen? Suppose x is greater than 1, huh?
It also equals to 1. It also equals to 1.
Yeah, but this term would be, I'm not talking about the limit, okay?
Correct.
If x is greater than 1 for each n, what about this value?
It's convergent.
Yeah, in last what we have done, here what we have done, see, if something is greater than 1, then its power, you have written like 1 plus h to the power n, right? So this is the proof, right? If something is less than 1, that means 1 by that one is greater than 1, and that to the power n, you have to see. Now in this case, if you want to apply similarly, what should I do here? So for each one, for each n, this value will be, for n equals to suppose 2, n equals to 3,
So
n equals
different.
to, yeah, so different is, yeah, okay, but this should value is, this value will be, suppose 0 less than x less than 1, huh? Then this value will be true,
No, sir.
huh?
No, sir.
No.
No, sir.
Hmm?
No, sir.
No, sir. Sir, if we take n equals to 2 and x equals to 2, we get 1.414.
No, in this case, this is this case I have not written till now, huh? Suppose 0 less than x less than 1, then is this true?
Yes, sir.
Yes, sir. It will be true.
That I am asking. Is this true? Whatever I have written above, if x greater than 1, then x to the power 1 by n is also greater than, for every n greater equals to 1.
दोनों true है, दोनों true है, दोनों true है,
Huh? True
दोनों
है?
true है.
हाँ.
Yes, sir.
So now what you have to do? Suppose x to the power n greater than 1, and you want to prove this limit. What you have to do? Whatever I have done here, similarly you have to follow similar procedure. Okay? Something is greater than 1, that means you can write x to the power 1 by n as 1 plus 1 plus 1 plus some depends on n, right? Some number, and then you have to check whether that sequential goes to somewhere or not. Okay? So x to the power, for each n, x to the power 1 by n is greater than 1. So write like this one. Okay? And dn is greater than 0. Now can you proceed similarly? Now can you proceed similarly? So now where dn should goes to? Where dn should go? You want to find the limit, right? So this is the first case for x greater than
tends
1.
to 0.
Huh?
Bn tends to 0.
Yeah,
Bn
that you
tends
have
to
to
0.
prove it. So we are considering the first case. That when x greater than 1, x to the power n is greater than 1 for every n. That means x to the power n is 1 plus dn, dn greater than 0, right? Now you have to show that limit of this sequence dn goes to 0. So that limit of the sequence x to the power 1 by n goes to, so that limit of the sequence x to the power 1 by n goes to
1.
1. So this is for this case. Then you have to show for this one, and for x equals to 1 also, you know that this is 1 to the power 1 by n, and that is your fixed sequence 1 for every n. So it will goes to 1 constant sequence. So this is exercise. Can you complete it? So this week I will take tutorial. So when is your tutorial? Thursday. If you have any doubt, you can ask on Thursday tutorial. Okay. So please try it. Please complete the proof for this one and this case. Similarly, similar type of approach. Okay. You have any doubt? Similar type of approach will hold. I am giving you some another example. So this will follows all the time. So limit n tends to infinity. 1 by root over n square plus 1. So everything using sandwich theorem, okay? So what you have to do if you want to apply sandwich theorem? What you have to do if you want to apply sandwich theorem?
We can take two function 1 by root x and 1 by root of x plus 1.
1 by root x and 1 by
Root of x plus 1.
so here what is your, suppose we have to bound like this one, right? A n, b n, c n. So what is b n here?
As the function that is written on the screen right
Yeah,
now.
so this is your b n, right?
The function greater
Yes.
than an and is smaller than cn.
Huh? What? What you are saying?
Sir, a bn is the function which is greater than an is smaller than cn.
Yes, yes. So Bn is given, what you have to prove it, right? The limit of the sequence, suppose Bn you have to prove it, right? In sandwich theorem, and it is bounded below via An and bounded above by the sequence Cn. So that these two you have to find. How will find An and Cn? How will find An and
Sir,
Cn?
we have to guess it.
No, no, no. Means guess it means you can prove it, right? You have to prove it. So what will be that? So suppose what will be the sequence Cn? Can anyone tell me what will be the sequence Cn? At least you should tell this one. What will be the sequence Cn? After looking at
1 by
that.
root.
What will be the sequence Cn? So suppose this term is bounded lesser equals to by. Is it true? Is it
Yes,
true
sir.
or not?
Yes, sir.
Yes,
Similarly,
sir.
Yes, sir.
all this term. So what will be your Cn then? What will be your Cn then? What will be your Cn then?
1 by root minus plus 1.
Huh?
Sir, 1 upon under root n square plus n.
So n by n square plus 1. Is it clear to all of you? Is it clear
Sir,
to all of
how?
you? So this is for all n greater equals to 2. Is it clear to all of you? Cn?
No, sir.
Yes.
No? Who has problem?
Sir, me.
Okay, so we have to see whether Vn is bounded by some sequence, right? Whose limit you know. So Vn is like 1 by root over n square plus 1. Okay. 1 by root over n square plus 2 up to 1 by n square plus n.
Yes,
So
sir. Clear now.
clear now?
Yes.
So because this term is, each term is bounded less than 1 by n square plus 1. So n term is there, right? So each term is less. Is it okay?
Yes, sir.
Similarly, you have to find what is mean by n. Okay, this is exercise. If you have any difficulty, you can ask on the tutorial class. Complete it. Huh? Now suppose un is a sequence converges to u. Okay, what will happen about the mod sequence? Suppose un is a sequence of real number, because we are basically here talking about only the real sequence, right? Converges to u. Then what will happen? What happened? This will converge. If un converges to u, then this will converge or not? What do you think? This will converge or not? And if it converges, where it will converge?
Sir, it won't converge. Sir.
It won't converge. Anyone else? Anyone else? Anyone else? Mod u. So in the beginning, let me see. In the first class, we have studied what do we mean by absolute function, right? And properties of absolute function. We have studied or not?
Yes,
Yes,
sir.
sir.
What are the properties of the absolute function? Let me see whether I have written it here or not. Yes. What about this property? Mod x minus mod y and then whole mod is lesser equals to mod x minus y, right? So can you use this property? The property number 7, mod x minus mod y whole mod is lesser equals to mod x minus y, right? So this is the application. Here you can see triangle inequality application, and there also you can use it here, right? This already I have written on the first class. So how will you use it? Now you can prove it that this, if the sequence un converges to u, mod of un sequence converges to mod of u. Now can you prove this one? Yes or not? Can you prove now? Yuvraj Singh? Yuvraj Singh,
Yes, sir.
can you prove this now? So what you have to do? Just you have to write that one, right? Who is
Yes, sir.
Moinak? Moinak, don't write anything, okay? This will be lesser equals to, tell me. This will be lesser equals to, just you have to use that inequality, right? Is it true
Mod
or
of
not?
un minus u. Yes,
Yeah.
sir.
So from there you can show that mod of un converges to u. What about converse? What about converse of this theorem? What about converse of this theorem? Suppose un converges, mod of un converges to mod u. So then can it does it imply that un converges to u? What do you think?
No, sir.
Can you give some example? Can you give some example? Can you give some example? Trivial example already we have studied. Can you just think of some example?
Sir, -1 + 1 -1 + 1. That example.
Just -1 to the power n. Yes, -1 to the power n. You are talking about this one?
Yes, sir.
So what is the mod of that sequence? So mod of un is -1 to the power n, right? That means
Yes, sir.
1 only, constant sequence.
Yes,
So it
sir.
will converges to 1, but the sequence
Yes,
un does not converge. Okay, you have any class now?
sir. CS class, sir.
Okay, so see you tomorrow, huh? We'll continue from here, okay?
Thank you, sir.
Okay, chalo.
Thank you, sir.
Yes, sir.